Okay, so we are backtracking just a little bit. We have 5.4b. Remember, we split 5.4 into two. Adding and subtracting was part A, and now part B is multiplying and dividing, and we're also going to be plotting. So just as a refresher, complex numbers have a real part and an imaginary part. The real part is the number. The imaginary part is the one that has the I attached to it. So we have a real part and an imaginary part. We always want to write the real part first and the imaginary part second. Okay? So even if it's not in that order after you're done simplifying, reorder everything so the real part is first and the imaginary part is second. As I was grading quizzes this weekend, which I didn't get to finish, you will have them back tomorrow, I saw a lot of you putting the imaginary part at the end, or at the beginning, and the real part at the end. You want to make sure you have them in this order. Okay? So, example 1. We have I times 9 minus I. What property does that look like? Distributive. So let's distribute the I. I times 9 gives me 9I. And I times negative I gives me minus I squared. Now this is not simplified all the way because I squared is equal to what? Negative 1. So this is the same as 9I minus negative 1. And what happens when I have minus a negative? It all becomes positive. So this is 9I plus 1. Now, is this in the correct order that complex numbers should be? No. So we're going to take that 1 and put it in front. So this is going to be equal to 1 plus 9I. And that's your answer. Not too bad? It's everything we already know. We're just attaching i's to it now. Any questions so far? Okay, let's look at something else that might look a little familiar to you. 3 plus I times 5 minus I. What does that look like? FOIL or box method. Use whichever method you want. I'm going to go with FOIL. 3 times 5 gives me 15. 3 times negative I is minus 3I. I times 5 is plus 5I. And I times negative I gives me negative I squared. Okay. Let's simplify this. Negative 3I plus 5I. What is that going to give me? 2I. So this is 15 plus 2I. And I squared is equal to? Negative 1. So that's minus negative 1. Minus a negative becomes a positive. So this is 15 plus 2I plus 1. So what would that give me as my answer? 16 plus 2I. Thumbs up, thumbs down. How do you guys feel about it? Thumbs up? Not too bad, right? Thumbs up and a smile. Okay, any questions so far? Okay, example 3. Five over 1 plus I. Okay guys, there are two things that are never allowed in the denominator. One of them is a square root. What's the other one? The I. I have a 1 plus I here, so I'm going to multiply by the what? Do you remember what it's called? Starts with a C. Conjugate. The conjugate of this would be 1 minus I. So we do the conjugate here because it's an addition or subtraction in the bottom. So we multiply by 1 minus I. I suggest you put it all in parentheses. And then let's do it. At the top is distributive properties. So we have 5 times 1 gives me 5 minus 5I. And at the bottom we have FOIL or box. 1 times 1 gives me 1. 1 times negative I is negative I. I times 1 plus I. And I times negative I is minus I squared. Okay. Negative I plus I, what happens there? They cancel. And I squared is equal to negative 1. So this is 5 minus 5I all over 1 minus negative 1. So that's 5 minus 5I all over what? 2. And that's your answer. So since we don't have I in the denominator or a root in the denominator, we're good. So we're done. Just so that you are aware, something that we see a lot in these types of problems is separating the two. So a lot of times we see this as an answer as well. 5 over 2 minus 5 over 2I. So these are the exact same thing. We just took the common denominator, and make sure you guys write this down. There we go. And split it up. So this denominator goes with each of the terms. So sometimes in order to make it as a proper complex number, we have to have the real part and the imaginary part separated. Okay, so just get kind of used to that. It also makes it a lot easier for our simplifying, if part of it can simplify but not the other part. So all they did here was they separated it into two numbers and took the denominator and gave it to both. Okay? Okay, example 4 is very similar. 5 plus 2I over 3 minus 2I. Okay guys, so what's in the denominator that's not allowed? I. So what are we going to do? We're going to multiply by the conjugate. Good. So that's going to be 3 plus 2I. And 3 plus 2I on the top as well. So this time you're doing FOIL or box on both the top and the bottom. I want you guys to try finishing it by yourselves. We will see what you get and just... Okay guys, so on top I'm going to do FOIL method. 5 times 3 gives me what? 15. 5 times 2I is plus 10I. 2I times 3 gives me plus 6I. And 2I times 2I? Plus 4I squared. Excellent. Okay, so we're not simplifying anything yet. We're just writing it all out. Let's do the bottom. 3 times 3 gives me 9. 3 times 2I plus 6I. Negative 2I times 3 minus 6I. And negative 2I times positive 2I minus 4I squared. Okay, let's simplify and combine like terms. I squared turns into negative 1. So this is going to give me 15. 10I plus 6I is plus 16I times plus 4 times negative 1. That's going to give me 9. So so it's multiplication.
Yeah, I put subtraction.
Yeah. 6i minus 6i cancels, and that's -4 times -1. Okay, so that is 15. -4 times -1 is -4. So what's that going to give me? 9 plus, not 9, 11. Did you say 11? Oh, I heard 9. Plus 16i all over 9 minus 4 times
14.
-1. So that's going to give me
14.
13.
Oh, 13.
And then they want us to split this up to make it a proper complex number. So that's going to be 11 over 13 plus 16 over 13i.
You have to split it up like that.
Yeah, because we want a proper complex number has the real part and the imaginary part separated. So just split it up, and then also if you can reduce sometimes you can reduce one part but not the other part.
And you add them? Or
and you just leave them. We can't add them because this is a real number and that's
an imaginary.
imaginary.
But you have to put it as you're adding?
Yeah, we put it as we're adding because that's the symbol right here. If that was a subtraction, it would be subtraction. Okay. Last thing we need to do with this is plot complex numbers. Okay. Plotting complex numbers is actually not that challenging. We still have an axis. Usually our set of axes were x, y. But for imaginary and real numbers, it's a little bit different. The real axis is what used to be the x-axis. So real numbers get graphed along the x-axis, which makes our vertical, or what used to be our y-axis, the imaginary one. Okay. So we have a real and an imaginary axis. And then let's look at this. In number A, I have 3 minus 2i. So my real number is 3. So as far starting from 0, I'm going to count to the right 1, 2, 3 spaces along the real axis. My imaginary number is -2i. So then I'm going to go down 2 spaces. And that's my point. And that's all there is to it. So before we had x, y for regular points. With complex numbers, we can just imagine that there's a comma right there and we graph the same way. So let's try this one together. My real number is what? -2. So I'm going to go to the left 1, 2 spaces. What's my imaginary number? +4. So I'm going to go up 1, 2, 3, 4, and that's where your point is. Make sense? So for C, 3i, what's the real number there?
3.
There is no real number.
Oh.
So it's 0, right? So what is the imaginary number? 3. So we just go up 1, 2, 3. This is an imaginary because there's an I attached to it. So then what about D? What's the real number there? 5. So go over 1, 2, 3, 4, 5. What's the imaginary? There isn't one, so you just put the number or the point right there. Try plotting E by yourselves. -3 minus 3i. So guys, on this one, what is the real number? -3. So am I going up or down, right or left?
Left.
Left, 3 spaces. 1, 2, 3. I don't put a point there because I'm not done. And then what's my imaginary number? -3. So is that up or down?
Down.
That's down. 1, 2, 3. Easy?
Yeah.
Plotting is not too bad, right? Okay, a couple more examples and then we are done. You are going to see some, like example 5 here. We're just going to do one. 3 over 1 plus 4i plus 4 over 1 plus 4i. For addition, I have to have what? Common denominators. Do I have a common denominator? Yeah. So we can just add the numerators. So this is the same as 7 over 1 plus 4i. Now, is that an acceptable answer?
You can't have I.
No, you can't have I in the denominator. So we also have to multiply by the conjugate. Mistake that I see on the test so often. Students get to this point and they think they're done. Okay, remember, I is never allowed in the denominator as an answer. This is not a complete answer. You have to finish the problem. Okay, so here I'm going to distribute. So that gives me 7 minus 28i all over. And then we're going to do FOIL method. So 1 times 1 gives me 1 minus 4i. 4i times 1 is plus 4i. And then 4i times negative 4i is minus 16. 4 times 4 gives me 16. I squared. So that is on the bottom. The 4 i's cancel. 1 minus 16 times negative 1. So that's the same as 6 plus 16. So this is 7 minus 28i over 1 minus 16 times negative 1 gives me 17. And then we want to break this up. So that's going to be 7 over 17 minus 28 over 17i. Nothing can be reduced, so you're done. Okay, so we do have, can find patterns when we are using I. So we're going to do 4 problems, and all we want to do is simplify this. So our first one, part A, is I to the 7th power. How can I simplify this? Let's multiply it all out. This is the same as I times I 7 times. 1, 2, 3, 4, 5, 6, 7. Now we know what I squared is equal to. What's I squared equal to? Negative 1. So how many I squareds do you see here? I see 1, 2, 3. So this is the same as I squared times I squared times I squared and then times I, right? Okay, so that gives me negative 1 times negative 1 times negative 1 times I. Negative 1 times negative 1 times negative 1. What does that give me? Negative 1 times I. So that simplifies to negative I. And that's your answer. In terms of I, you should never have an exponent greater than 1. Because if you have I squared, it's negative 1. If you have I to any other power, you can always reduce it down to just an I, or no i's at all. So let's look at B then. I to the 8th power. That's I times I times I 8 times, right? 4, 5, 6, 7, 8. I ran out of room.
Do we have to write it all out like that?
For this one, yes. Not always. We're going to find a
3
pattern.
times.
Yeah, no. We're going to find a pattern. We're looking for I squares. How many I squares are in I to the 8? 1, 2, 3, 4, so that's I squared times I squared times I squared times I squared. So that's -1 times -1 times -1 times -1, which actually gives me what? +1 as your answer. So what's the pattern here?
If it's a negative, then it's a negative I.
If our exponent is even, our answer comes out positive. If our exponent is odd, it's going to come out as negative. What about when I have I or 1? Any suggestions there?
If you have what?
It has to do with what our answer comes out to. So here's the rule. Let me write it down for you. We're going to take our exponent and we're going to divide by 2. So divide the exponent by 2. If our exponent is even, if the answer is even, you're going to get a positive number. Let's just write positive. If our answer comes out odd, it's going to come out as negative. So what we're going to do is if we have an odd number, we're going to write it first to get an even. Okay? So let's look at this. 81. I to the 81. Does everybody agree that that is the same as I to the 80th power times I?
Yes.
Are you guys okay with that?
Yes.
Or it's not positive, it's +1. And it's -1. Sorry, guys. So it's not just a negative number, it's specifically 1. So a +1 and a -1. So if you have an odd number exponent, first write it out as an even exponent times I. Okay? And then what are we going to have? 80 divided by 2. What does that give me? 40. Is that an odd or an even number?
Even.
Even. So my answer is going to be +1 times I. So what would my answer be? Positive I. If we look back at number 7, that's I to the 6 times I. 6 divided by 2 gives me 3, which is an odd number. So that was -1 times that I, which gave me the negative I.